Alright guys, we'll give this a minute for some people to join. And then go ahead and get today's lesson started. Let's see if Mallory joins. Alright, today, what we're going to do today, guys, is to take the one property we didn't really focus on yesterday and focus on it today. So today is basically like splitting up integrals. So if I have the integral from a to b of a function, that's the same as the integral from a to c of that function plus the integral from c to b. I like to think of this like more like a number line, even though integrals are technically like areas underneath the curve. It still works the same way. So if I have 2 points, A and B, on a number line, and I know the distance or the value between those 2 points, let's just say is, I'll just make up a number, 18. So if I know from here to here it is 18. Well, logically speaking is, if I pick a point in between, so say point C, if I find that the distance from A to C would be, 3, and then from C to B would be 15, that makes sense because 3 plus 15 is 18, which is the same distance all the way across. So I like to use this to kind of help us with integrals, where we can split up the integral into different parts. So we're going to go through today's examples to kind of help you out. So the first example, they give us a little bit of information. They tell us that the integral from 0 to 5 of the function is 10. So I'm going to write these up here. The integral from 0 to 5 of function is 10. And also the integral from 5 to 7 of that function is 3. So if we think of this like a number line, 0 to 5, its distance would be 10, or its area, or whatever we want to call it, is 10, and from 5 to 7, its area is 3. Oh, hey, Sage. Sorry. Okay, so the first couple questions here. A is asking us this. Okay, what's the integral from 0 to 7? All right, so a couple things about this. 0 to 7 should be pretty easy. What we have to do is what's the total coverage area, or the total distance, or area, whatever you want to refer to it. It's technically area. Well, we'll just add those two together. From 0 to 5 is 10. From 5 to 7 is 3. So from 0 to 7 would be 13. Next question, B. What's the integral from 5 to 0 of f of x dx? Okay, so remember, if we go backwards, not from 0 to 5, but from 5 to 0, it's going to be the negative. You think about it, if we added 10, then added 3. Now, if we wanted to go backwards, we'd have to have the negative value of that. So that would be a negative 10. Anytime we have the same thing, but the A and B are flipped, it's the negative response. All right, here's another property, just reviewing from yesterday. What's the integral from 5 to 5 of f of x? So this example using the number line kind of helps illustrate this point here. So if I start at 5 and end at 5, what did I add to this equation? I added nothing, so that would be 0. Alrighty, I'm kind of running out of room here. So I'm going to leave those up for a second, and I'll do the last problem here. The last one, D. All right, and then problem D on the first one here is, okay, what's the integral from 0 to 5 of 3 f of x. Well, if we know from 0 to 5 it's 10, and if we have 3 of those, we can just use that constant power. So 3 times 0 to 5 is 10, so 3 times 10 would be 30. So there should be the first 4 answers there. All right, we'll do another example problem and go through this. Okay. Very similar problem, but we have a slightly different scenario going on. We have the integral from 0 to 3 of that function of a function is equal to 4. And then the integral from 3 to 6 of that same function is equal to -1. All right, so I'm going to draw out a number line just so I can visually see what's going on. All right, so from 0 to 3, we'd have an area underneath the curve of 4. And then from 3 to 6, its area underneath the curve is equal to -1. We'll talk about that later, like graphically. What does that mean to have a -1 area? Because that doesn't really make sense. All areas should be positive. But when it comes to integrals, we can technically have a negative area. It's just the location of the area. And so when we look at graphs, we'll explain what that means. But that's for another day. Okay, so we got 4 problems here. First one, starting it off. Well, write's a little smaller here. What's the integral from 0 to 6 of that function? All right, well, 0 to 3 is 4. 3 to 6 is -1. Put them together. That's an integral of 3, a total integral value of 3. All right, next, B. What's the integral from 6 to 3 of f of x dx? Well, if we know from 3 to 6 it's -1, if I go 6 to 3, it's got to be the opposite of that, a negative answer. And a -1 is a positive 1. So from 3 to 6, if we go backwards, we get the opposite answer. All right, for choice C, from 3 to 3 of f of x, anytime we start at a number and end at that same number, we have a total displacement of 0. So that would be an integral of 0. And then last problem here. What is... Can I squeeze it over here? I might be able to. I'll use a different color. The integral of 3 to 6 of -5 f of x dx. Well, if we know from 3 to 6 it's -1, but we're going to do -5 times that. So it's going to be -5 times -1, which would be a +5 answer for that one. Okay, so pretty easy stuff, guys. If we take a look at what we're going to do tomorrow, give me a second here, I'll click. You might want to go ahead and move on to that. Let me preview this. Yeah, tomorrow is extremely similar, except for it's f of x and g of x. But I think you guys can handle that one. You guys should be fine. If you want to do that, then you can get your weekend started early. I'd recommend that. All right, best of luck. See you guys tomorrow. Bye.